Good morning, Year 11. So going to go through the first 2 pages of those sheets I gave you for revision. So let's start on the first one. So we need version A. That's the one I'm going to go through now. So make sure you find version A, and I'm going to go through the first 2 pages. It starts with standard form, so we need to get our calculator because this is for a calculator paper. And I'm going to show you and make sure that you know how to do standard form on your calculator. So have that at the ready. So the first question is to calculate 2 times 10 to the power 5 times 4 times 10 to the power 5. Now you could actually really easily do this without a calculator using your rules of indices. 2 times 4, which is 8, times 10 to the power of, and then you add your powers. 5 add 5, which is 10. However, it's probably going to be a little bit more complicated. It might have some decimals in there. So we are going to talk that through, what it is like on your calculators. So on your SharpWrite calculator, if you have one of these, your standard form button is the EXP button. So looking at your worksheet, the first number that we need to put in is 2 times 10 to the power 5. So you press 2, you don't hit the times button, you go straight in and press EXP. That E there means times 10 to the power of, and then you're going to put in the 5. That's all you need to do. Now you do need to hit that times button because that's the operation. If it's a plus, divide or minus, you pop the operation in now. So we want to times that by, and then pop in the next standard form number. So it's a 4, no times button. Just hit your EXP button. You do not press the power button. The EXP does everything. If you start hitting a power button, it's going to go wrong. And then you press the 5 and then press equals. So this is now giving me a number in standard form. This says 8 times 10 to the power of 10. Your calculator may write it as an ordinary number, in which case on your calculator you'll see an 8 with then 10 zeros. So it may come out like that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You'll then just need to, if it comes out like that, pop it back into standard form. So your decimal would go after the 8, and then counting down, it jumps down 10 more places. So 8 times 10 to the power of 10. Let's try our next one. Again, this is actually quite straightforward. I'd expect to see this more on a non-calculator paper. However, we are going to put it onto the calculator because you're going to have one with possibly decimals here. Without a calculator, I would do 12 divided by 3, which is 4, times 10 to the power of, and then just take the powers away. 8 take away 4, which is 4, so I know what the answer is. However, let's put it through the calculator. Now, whenever you have a fraction with standard form, hit your fraction key, which is A/B. And then you're going to program in the top number, so that's a 12. And then it's a times 10 to the power of 8. Then use your down arrow to get to the bottom. 3, EXP, 4. If you have a Casio, down here at the bottom, it literally says times 10 with a little letter for the power. Hit that button instead of our EXP and do it exactly the same way. Press an equals, so this time annoyingly it's giving it as an ordinary number. You are going to have to in your exam most likely pop it in standard form, so you just have to convert that. So 4, the decimal would go there, 1, 2, 3, 4 bumps down, and there we have a match. When adding, you can add the numbers provided the powers are the same. So because the powers are the same, I can do 4 add 2, which is 6, and then because we're adding, the powers will remain. Now I did that without a calculator. You're probably going to get one with a decimal here and a decimal here, so let's put it into the calculator. 4 EXP 5, add 2 EXP 5, and then press equals, and there you have it. Your calculator has given it as a standard, as an ordinary number. Pop that into standard form. So the decimal would go after the 6. So 6 times 10 to the power of 1, 2, 3, 4, 5. Don't count the zeros because that's just a single number there on its own. The zeros are the power, but if that was a number and that was a number, you can't just rely on counting the zeros. Okay. Translations, transformations. Let's have a go at these now. So first one we need to do, translate shape A by the vector. 5, -4. Now your top number tells you whether to go right or left. So because it's positive, you're going to go 5 to the right. The number at the bottom tells you whether to go up or down. Because it's a negative, we're going to go down. So that means 5 to the right, 4 down. You have to go from the same point. So I'm going to take the one furthest to the right. I just think it's going to be easier. And I need to move that point 5 to the right, 4 down. 1, 2, 3, 4, 5. And then 4 down. 1, 2, 3, 4. It's going to end up there. The biggest mistake people make is they forget that they have to draw it from the point that they moved. And some people turn this bottom right into, say, the top of the triangle. It has to be this point here moves here. And then you draw the rest of the triangle from that point here. So it's 2 to the left from that point there. And then I need to go 3 up. And then it should join back down to that point there. So you're moving that point, that vertice there. There we go. Okay, next one, we are describing this translation. Well, we're describing the transformation, and it is a translation because the shape has just moved on the grid. So you must write the word a translation to get the full mark. So it's a translation. And then for this, you have to write the vector. So we know it's a vector because we've got a translation. So I'm going to open up my squared brackets to put 2 stacked numbers. It must be the same point to the same point. So identify one point on one triangle and the same point on the other triangle. So it must be same to same. And then count. Now, A to B, we're going to have to go left first. 1, 2, 3, 4. And then 1, 2, 3, 4, 5. So it's gone 4 in this direction, and then it's gone 5 down. Well, left is going to be negative, and it's gone left 4, and down is negative, and it's gone down 5. So -4, -5. Okay, on to the next one, which is a reflection. So I'm going to do this one and then this one because they are both reflections, and then move across. So reflect shape A in the x-axis. Remember, the x-axis is this one here along the corridor first, and then your y-axis goes down there. Now, reflecting in the x-axis means you use the x-axis as your mirror line. So I am going to just mark it on a bit stronger, and that's the line we need to reflect in. Count how many squares away it is from the line and repeat that. So this vertice there, it's 1 square away, so repeat it, 1 square away. This point here, 1, 2, 3 away, 1, 2, 3 away. And then this one, 1, 2, 3, 1, 2, 3. So you're just counting the distance from the mirror line and repeating that above the mirror line. Do use a ruler and use a pencil. I know I'm not, you should be using a pencil in your exam, please. Describe fully the transformation that maps shape A onto B. Well, I can see this is a reflection, and I just need to find the halfway point now. So halfway between these two vertices here is there. So I can just draw a straight line across there. So this is called a reflection. So you must write the word reflection. And then you have to write in the line. And then you need to name the mirror line. So to do that, it's cut through at this number 1 here. You need to identify the axes that 1 is on. And that's gone through your y-axis. So if you label the axes it's gone through. I think this will make your life a bit easier. So it's the y-axis it's cut through, and it's cut through at number 1. Just pop those two next to each other. So y equals 1. Okay, onto our rotations. Now whenever you do rotations, you need your tracing paper, so hopefully you've kept yours safe. We need to do a rotation 90 degrees clockwise about 0, 0. So first of all, I'm going to draw around the shape. I should probably use a ruler. Anyway, draw around your shape. We're going to rotate it about the coordinate 0, 0. Now the coordinate 0, 0 is here. I'm just going to draw a little cross there so that I can see when that cross lines up with itself. So 0, 0, 90 degrees clockwise. So you're going to put your pencil, hopefully you've got pencil there, and 90 degrees. So that's a quarter of a turn. So I'm just going to turn it until that cross maps back onto the axes again. There we go. This is why using a ruler would have been much better for me. So I can see one vertex is there. And I've got another one coordinate there and one there. There we go. Use your ruler and join them all up. There we go. So we've gone clockwise 90 degrees about the coordinate 0, 0. To describe this one, we can see it has been rotated. So you're going to need your tracing paper now to see at what point was it rotated. So let's use a ruler. Trace around your shape A because we want to go from A to B. And this one's fairly straightforward, but sometimes in the exam they may be a bit tricky. So start off by putting your pen or pencil on the origin at 0, 0, and then just rotate and see if you map back up with your original shape. And I can see, well, not the original, with the new image. I can see here it maps back on here. Now if that didn't work in your exam, it will always be one of the coordinates around the origin, so you're just going to have to try another one until you get one that works. But for this one, putting my pen on 0, 0 and rotating it, that's a quarter of a turn, that's a half a turn, and half a turn is 180 degrees. So I've got my rotation, so it's a rotation, and it was 180 degrees. Now I don't need to write clockwise when it's 180, but just to form a good habit I'm going to write it in. So you need to write rotation, you need the angle, you need the direction, and then you need about and the coordinate where you put your pencil to make it line up with itself. So that was at the origin, so that would be called 0, 0. Right, last one, enlargements. So enlargement scale factor of 2, and then the centre is 1, 1. So that means we need to double the distance from 1, 1 to each of the vertices of triangle A. I'm going to start with this one here. Now you don't have to write it as a vector, but I'm going to do that just to try and make it a bit clearer. So to go from here to here is 1 to the right, 1 up. So it's 1 to the right, 1 up. What we need to do is double that, so it's going to end up being 2, 2. You do not have to do this. This is not extra workings. I mean, this is extra workings. You do not have to write this. I'm just doing it to show you. So instead of going 1 to the right, 1 up, we need to go 2 to the right, 2 up. 1, 2, 1, 2. So that's going to end up there. To go from 1, 1 to the bottom right, it's 1, 2, 3 to the right, 1 up. So times that by 2. And then we're going to go 6, 2. So 1, 2, 3, 4, 5, 6, 1, 2. And then for the top one, it's 1, 1, 2, 3. So times that by 2 and we get 2, 6. 1, 2, 1, 2, 3, 4, 5, 6. There we go. And then we can join all of that up. There we go. So we've enlarged that scale factor 2 from the centre 1, 1. Right, last one for today. Describe the enlargement. So we need to go big shape to small shape. So in this direction here. And then big shape to small shape. So you match up the same points on both triangles and draw a line. Always go big shape to small shape. And then the point they cross is your centre of enlargement. So it has enlarged. Even if it gets smaller, it's still called an enlargement. So enlargement, scale factor. Now you need to work out the scale factor. The base was 1, 1, 2, 3. The new shape is 3. 3 divided by 1 is 3. So scale factor is 3. And then we say about, and then you put the point where the two ray lines cross, so about 0, 0. Now I did give you larger sheets for these transformations. And I can't remember if I gave you larger sheets for version B and version C, and apologies if I didn't, and it's quite hard for you to do those. What I will do is on Arbor pop the file so you can print it at home if you have a printer and make it a bit bigger. So have a go now at version B and version C. So if you flick through the booklet, there's a version B and C. So you can now try this on your own twice. So find version B, C, pause the video. Once you've done it, press play. Okay, so hopefully you found version B and C. So here's my answers. Version B, standard form, 8 times 10 to the power 7, 2 times 10 to the power 4, and 6 times 10 to the power 4. Ended up looking a bit like this at coordinate 2, 6, 5, 6, and 5, 8. And this was a translation for negative 4. Reflected in the y-axis, it should have ended over here at negative 2, negative 1, negative 2, negative 4, negative 4, negative 4. This was a reflection in the line y equals 1. Your rotation should have ended up at negative 2, 1, negative 2, 4, negative 4, 4. And this was a rotation 180 degrees. I'll put in clockwise, although you don't need it, about 0, 0. And then for this one, it ended up looking a bit like this at coordinates 3, 5, 6, 5, and 3, 8. And this was an enlargement of scale factor, I don't know why I put 4, I don't think it is a 4. 1, 2. 1, 2, 3, 4. I forgot to do the division. So a scale factor of 2 about the coordinate 1, 0. And then you should have looked at version C. So 1.6 times 10 to the power 10, 3 times 10 to the power 4, 6 times 10 to the power 5. Coordinates 5, 3, 7, 3, 5, 6. This was a translation for negative 4. Annoyingly, that one didn't change. X-axis is this line here, so it should have ended up down here. Negative 2, negative 1, negative 4, negative 1, negative 2, negative 4. This was a reflection in the line where x equals 1. Rotation of clockwise should have ended up here at negative 3, 1, negative 3, 3, negative 1, 3. And the bottom one was a rotation 180 degrees clockwise about 0, 0. The enlargement should have ended up at 5,38359, and then the bottom one was enlargement, scale factor of 2, about the coordinate 1, 1. Okay, well done on those ones, guys, and best of luck with all your other bits of revision today. Have a good day, guys. Thank you very much. Bye-bye.